So let's say that is the randomness, the Brownian motion of an amoeba in the fluid in your eye. That's the path it made. Lean's gone. Okay, now careful, always look at the scale. Is each line a 1? No. And to make matters worse, the x and the y are different scales. So what is domain again? Sure? Domain is x values. So when you say domain, x, okay, x, ask yourself the question, what are the x values of this graph? It goes from what to what? Okay, and how do we get, how much is this? Do you go like, let me try 3, 6, 9, 12, 15, no. Let me try 5, 10, 15, 20. 12. What's the quick way to do this? I got 1, 2, 3, 4, 5 lines. That equals 20. So each line must be 4, right? 4, 8, 12, 16, 20. Okay, who's got it? What's the domain? Anybody else? Other than Alicia or Tyrell? Because I know they got it. Or Colton. I know he's got it. Okay, Colton, what do you got?
X is more greater than negative 8. Less than or equal to 6.
Okay. Why did you not include 8? Because it doesn't include negative 8. Sorry, right? Negative 8. That's a whole. It doesn't include that point. It's everything greater than that point, but doesn't include that point. Okay? And then we got to add this. It's all of the real numbers, all of the fractions, all of the decimals from that point up to and including this point, which is, that's 10. 10 divided by 1, 2, 3, 4, 5. Each one of these lines is 2. 2, 4, 6, 8, 10. Okay? Up to and including 6. Just keep your eyes going horizontally. I don't care about up and down. I'm just talking about domain. Okay? Don't even look in this direction. That's all you do. It's just a line from here to there. That's exactly the same as this squiggly graph as far as the domain goes. Okay? Range, I'll say it, it goes from here, that point, all the way up to, including everything up to that point. Okay? So the range is exactly the same as that line. What are these 2 points? That's minus 20. Each one of these is 4. That's minus 4, minus 8, okay, up to, that's negative 4, sorry, positive 4, positive 8, all right? Doesn't include this point, but it does include negative 8. So that's how we do that. Oh, where y is all real, okay? Ask yourself the question, range, it's all the y values of this graph, okay? Then you got to try to piece it together. Okay? That's about as hard as it's going to get. Let's look at a second one. But first, to confuse you even more, there's another way to write this. This is called interval notation. You don't need to know that, but you do need to know, you can also write it like this. Okay? This is called set notation. It's not even in our book, but you could get it on the government exam. Okay? I know. Why do they have like more than one way to do it? I can't answer that question. What's your answer, Kelvin? What's your answer? To why do they have, why do they give you more than... Oh, okay. fine. Right? So what does this mean? There's a round bracket and there is a square bracket, or if you're Aussie, parentheses. All right? This square one includes this point. So if it's less than or equal to, it's a square bracket. If it doesn't include the point, it's a round bracket. All this says is everything in between these two numbers, from -8 up to 6, including 6. Okay? Same thing for range. All right? It's another way to write it. I'll say that again when we do our review. All right? How about this guy? What's the domain? What's the range? This one has an arrowhead. Think some more. What's the domain? What are the x values of this graph? You visually just want to look here. Okay? How far does it go? How far does it go this way? Does it go that far? Does it go farther? Does it keep going? How far? Yeah, that far. Every x value you could possibly think of down to and including that point. But you can't give me that as an answer on the test. You got to write it in math language. How do you write every single point of x up from including, what is this point? That's -5, so these are, each one's 1. So everything above greater than -2. How do I write that? Like that. Okay? Every value of x. X is the sum of all real numbers greater than or equal to -2. Okay? And then all this stuff, yeah, I know it's x, it's domain, but they still write that, okay, to make professors happy. All right? Range. Get rid of that. What is range? Range is the y values. What's the y values of this graph? Now keep your eyes just going vertically. Don't look horizontally. I just want the y values of this guy. How high up does it go? Yes, we're going to assume that keeps going. It doesn't stop. That's what the arrowhead means. Okay? If you see an arrowhead, it keeps going forever and ever and ever. Not only this way, but also up. Okay? So it goes all the way up to plus infinity. And it goes down how far? To this y point right here. Okay? As a vertical line, that's how I could write the range of this thing. Okay? What is this point? Well, that's -4. Yep, that's -1. Okay? No tricky graph here. How do I write in math the English of every single y point from -1 up? Like that. Okay? Y is greater than or equal to -1. Can I also write it like that? Does that say the same thing as this? Yeah, I just read it from right to left. Y is greater than or equal to -1. Okay? The greater part goes towards the y. Right? The smaller point goes towards the -1. If you like doing your alligator thing, fine. Okay? If it works, great. Okay? But you can't see, looking at this, whether y is a bigger number than -1 or not, can you? It's not two numbers here, it's a y. So I've seen people try to do that and screw it up. All right? But usually you want to write it like this. Every single number, y is the sum of all real numbers, bigger than or equal to -1. Okay? It's the same as this. How's this in set notation? Because I don't have number here, you just use this. Okay? What's the domain in set notation? It includes -2 and goes, Alicia's hurting her neck, here we go. It includes this point -2, okay, and goes all the way out to positive infinity. Why is an infinity in a square bracket? Again, some professor got mad and said, you can't include infinity because you don't know what number that is. Okay, so that one's got to be a round bracket. Okay, sorry guys, I didn't make the rules. We just got to follow them. Okay, the range is from -1 up to positive infinity. So that's how we write it. It includes this point, right? So we square bracket. Okay. 455. We jumped a couple of chapters because we're not focusing on graphing calculators. Review. Still doing relations between two quantities. Now we're looking at what the heck is a function. Okay? It's a special type of a relation. We can represent this in words, in mapping. Those are those funny arrows. A table of values, which you probably would graph back in grade 8, maybe even 9. An equation, y equals 2x minus 6. Set of ordered pairs. Okay, if he gave you a whole bunch of those, you could plot it and make a graph. A relation, each element of the, or each point of the domain, also called inputs, also called independent values. 95% of the time it's x, okay, is related to an element or elements of the range output dependence y. All right, what's a function? Let's get right to the definition. Function. It's a special type of relation in which each element, each point of the domain is related to exactly one element of the range. Okay? What's another nice wording? Or each input has only one output. That says the same thing. Okay? They get all these weird words like element, and we're still kind of screwy with this domain word, all right? Element, range, okay? Each input has only one output. If that's the case, it's a function. If it's not the case, it's not a function. There should be some easy marks on the test. Okay? You just got to remember that. Let's backtrack. All right? I'm not going to look at that. Okay? I'm not going to look at that. No, let's go here. All right. So, how can we tell if a relation is a function by looking at an arrow diagram? I'll write it first. If only one arrow leaves every element or point of the domain, then it is a function. Okay? So, for example, simple one. I got 3 and 4. Are those my inputs or my outputs? Which one's on the left? The independent or the dependent? Independent. Okay? Let's say these map to 4 and 6. Is that a function? Let's go back here. Each input has only one output. Here's my input 3. Does it have just one output? Yes. Does 4 have just one output? Yes. So that's a function. Okay? Whereas, I'll do it in red because it's wrong. If that's what I have, and 3 maps to 4 and 6, does that input have just one, only one output? No, it has 2 outputs. Okay? If this was a computer program and you're writing something and you say, if this, then do that, or this. it'll crash. Okay? Computers are really smart. They follow instructions perfectly, but try to make it think and make a choice, doesn't know what to do. This one, no, toast. Okay? Ain't gonna work. Okay? It wouldn't be a function. This is not a function. All right? So let's repeat that again. If only one arrow leaves each element of the domain, it's a function. Only one arrow leaves this one. Only one arrow leaves that one. There's two arrows leaving this point, not a function. Okay? Our original wording, this input has two outputs, not a function. All right? Ordered pairs. This should be easy pickings. There's an ordered pair. Okay? Here's an ordered pair. There's an ordered pair. Which ones are the inputs? Which ones are the independents? Which ones are the domain? X. Okay? This one has just one output. This one has just one output. That one has just one output. Okay? Each one of these elements of the domain has a unique output. That's fine. No, I screwed up my colors. Oh well. That's a function. That's okay. All right? But what if I have that? 5, 7, 3, 2. Is there a different output for the same input? There's 3, 4. There's 3, 2. Computer's going to crash. Okay? Not a function. Okay? Because I have two different outputs for the same input. All right? You can only have one output for each input. Okay? That's all you got to look at and recognize. That'll be a question on the test. That'll be 1/30th of your test. Should be an easy mark. Is this a function or not? Okay? Which one is not a function? Multiple choice. There's 4 answers there. Which one is a function? Okay? Graphing. Well, can you see that color? Not really well. Okay. If I have a graph like this, here's my x, there's my y. It's got a different value of y for that value of x. Here's x, here's y. Different output. Here's x, here's y. That one's okay. Okay, that's a function. But what if I have this? For this value of x, I have two of the same outputs. Okay, by definition, that's not a function. Okay? As a graph, classify the following statements as true or false. For each input value, there's only one output. That's the only one I'm going to do here, okay? That's our definition of a function again. For this graph, well, you just look at your x's and see if you got more than one value of y. Let's go over to this value of x. I don't know what that is, minus 3.5. My value of y is probably going to be about there. That's okay. That value of x, I have a value of y. This one, value of y. Is every x point here got its own unique output? Its own unique value of y? For each input, is there only one output? Yeah. Okay? You can't find me a value of x that has two different values of y on this graph. I'll show you an easy way to do this in a sec. Okay? True. How about graph B? I'll let you look at it. Look at all the values of x. Is there only one value of y? Or do you see two values of y for the same value of x? Okay? Doesn't matter where you go. Let's pick this x. Only one y. Let's pick this input. Only one output. Let's pick this domain. Only one range value for that domain point. Okay, that's fine. See how C is going to be different? Let's pick this x point, minus 2. There is a value of an output, but I have another one too. I have two outputs for the same input. Okay? There's not one output, there's two outputs, so this is false. Is this a function?
No.
It's not. Okay, let's go right to the beginning. For each input, it can have only one output, right? Let's find another one. Here's an input, x is 1. I got two values of y. What's this computer program going to do? Is he going to choose the top one or the bottom one? He doesn't know, so he's just going to shut down, okay? Can't tell him to think. I could have a random program, and it might choose this or that, but that's something else, okay? Graph D, same thing. Look, there's an x point. I got two values of y, okay? Ain't going to work. Now, you're going to like this. The vertical line test. If it's a graph, all you want to do is draw vertical lines. If it cuts it in more than one spot, it's not a function. Okay? So that's exactly what we were just doing. Let's try the vertical line test. Can I draw a vertical line through this where it cuts this graph only once? Or let's word that differently. Can I draw a vertical line that cuts it more than once? Yes, I can. Not a function. Okay? Here too. Not a function. I don't care how many vertical lines you draw on this graph, it's only going to cut that line in one spot. That's a function. Okay? So if it's a graph, use a vertical line test. Doesn't matter where I draw a vertical line here, it's only going to cut that graph in one spot. That's a function. Okay? That's a function. These aren't. So let's do a hypothetical one. There's my graph. Is that a function?
No.
Is there a line vertically I can draw that'll cut this graph? That one's okay, that one's okay, that one's okay, that one's okay. Hey, looks like a function. Oh, wait a minute. That one cuts it in 1, 2, 3 spots. Not a function. Okay? So that says the same thing. There is some input that has 3 different outputs. Okay? This x point there looks like x0. All right? So, a couple of examples. Which of these are functions? Is this a function? What do you do if it's coordinate pairs? Don't yell it out. You look at all these numbers and see if you have a duplicate. Do I have a duplicate value of x? I don't. For that input of 6, I have 2 different outputs. Not a function. Okay? That's all you do. If I was graphing this, it would look like this. I got all these other points, and I've got 1, 2, 3, 4, 5, 6. 6 is 7, but 6 is also 8. Does that pass the vertical line test? No, it does not, because it cuts that graph in 2 points, not 1. Okay? Is this guy a function? Just look at all your inputs. Are they all different? Then that's okay. If I graph that, all the points will have different y values, okay? And it passes the vertical line test. How do you know if that's a function or not? Let's go back. I know I saw something back here with arrows. All right. That is a function. This isn't. As long as I don't have 2 arrows coming from one of the inputs, it's a function. Okay? 1 arrow, 1 arrow, 1 arrow, that's okay. That's a function. Okay? Is this funky graph a discrete graph? Yes, it is. Is that a function? Does it pass the vertical line test? Yep. 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 Nope. Not. Okay? I know it says explain. I'm not going to write it down. I'm saying it as I'm going. What's the answer for that? Because it doesn't pass the vertical line test. Okay? Okay. This relation connecting the provinces and territories. Let's look at that. That's socials. F. Is that a function? Does it pass the vertical line test? Yeah, I don't think there's anywhere you can draw a vertical line that will cut this graph more than once. Looks fine to me. How about this funky thing? Definitely not. 1, 2, 3, doesn't work. Okay? So one other little thing. This looks really weird because it's this arrow mapping stuff. It's just substituting. Okay? They're saying that this is the domain. What is the range? Okay? As function f of x maps to that function 3x plus 1. Here's all you do. Take minus 1, substitute it in there. 3 times minus 1 plus 1. It's just like graphing, right? X and Y table. Use some values of x. We got some function that we want to graph it. What are my outputs for these inputs? If you're not given any, that's probably the ones you want to start with. Okay? These I'm given some. And then I got to think up 2 of my own. So what is 3 times minus 1? Minus 3 plus 1. If my input is minus 1, my domain, my output, my range is minus 2. Okay? What if x is 0? This one's easy. 3 times 0? 0 plus 1, that's 1. Okay? There's nothing here. I don't know. Let's choose 1. If that's a 1, I got 3 times 1 is 3 plus 1. So 1. If I input 1, I output 4. All right? I don't know. Let's go 2. 6 plus 1, I get 7. So what are the elements of the range? Those are my outputs. Okay? That's it. Minus 2, 1, 4, and 7. Show this as an arrow diagram. Okay, there's my inputs. What are my outputs? Minus 2, 1, 4, 7. And they use these arrows. Minus 1 becomes that. 0 becomes that. 1 becomes 4. 2 becomes 7. Okay, we don't use this in grade 11, so I don't know. Again, I asked myself the question, why are we teaching this? I don't have the answer. I just do as I'm told. Okay? Ordered pairs, well, just write them all out. Okay? As a Cartesian graph, what other kind of graph do you guys know how to do? But it's always going to be on this two-plane x and y coordinate grid. That's what they mean by Cartesian, right? I think that's the only way you guys know how to graph. What else do we do? Okay, there's the function. What are the inputs? What are the outputs? You just graph it, right? Minus 1, minus 2. That's down here. Okay? 0, 1, 0, 1, 1, 4. Yeah, there it is. 2, 7. There it is. Does it kind of look linear? Okay, do I join it? Don't I? I don't know. I don't know what it means, so I better not join them. Okay? Is it? 1 to 3, 5, 9. Some of you guys have a test at lunch. Okay, try to get here